If you're diving into Amazon Redshift and you are serious about learning by doing, you are in the perfect place. Because in this video, we are going to do hands-on with some real-world examples that will help you master Redshift from beginner to advanced. If this is your first time here, or you haven't seen the part 1 yet, I will strongly recommend going back and watch that first. In the part 1, I have explained Redshift important concepts like distribution key, sort key, encoding, table design in general, which are the building blocks of performance tuning. So you will find the link in the description box below, and it sets the stage for everything we are going to do in this video. So my strong recommendation is you pause this video, go and watch the part 1 first, and go through the concepts, and then come to this part 2 where it's all about the hands-on. So what we are going to do in this video, in part 2, it's all about the implementation. So we are going to create some tables. We'll see what is the optimized way of writing tables, what is the bad way of creating a table in Redshift. We'll load some sample data into the tables. We'll also use a copy command to load a CSV file into a table. We'll analyze compression and the impact on IO. We'll compare bad SQL queries with the optimized queries, and we'll see performance improvement in action as well. So if you are a beginner, don't worry. This is going to be super easy to follow. I have kept the examples very simple. I have not overcomplicated the things, and you will learn so much by actually doing it yourself. And hey, if you are finding this helpful and you want to support the channel, it would mean the world to me if you could give video a like, subscribe to the channel if you haven't already, and drop a comment below. Let me know what you find useful, or just say hi to me. Also, I'm working on part 3 of this Redshift masterclass, and where I'll explore more about Redshift Spectrum and how Redshift interact with other AWS services like AWS Glue, DynamoDB, S3, and more. And it is going to be a really powerful if you're working in a data lake or the hybrid environment. So if there is anything specific you would like me to cover in part 3, drop in the comments. I always read and respond to the comments, and I love to tailor my content as per your need. So, all right, let's get into it. Fire up your Redshift cluster, grab the SQL scripts from the description box, and let's start building. Okay, so I have logged in into my AWS account. I have already set up a Redshift cluster in the part 1, and we'll reuse that cluster here. The node type was DC2 large, and there are 2 nodes in it. Now I see a message here that April 24, 2026, the DC2 clusters, the nodes will reach end of life. So it is suggested that everybody who is using DC2 type nodes should migrate to RA3. I think that's much better also, because everybody is using data lakes now, and RA3 has much better support for federated queries. So yeah, but we are good for this demo. So my cluster is available now, and this is what we are going to do in this video. We will do hands-on related with designing table structure in Amazon Redshift. Before I proceed, I want to show you how many nodes and slices we have. If you are coming from part 1, you know I mentioned that I want to have at least 2 nodes, so that when I do the hands-on demo, it will be easier for you to understand. So you can see here there are 2 nodes, node 0 and node 1, and each node has 2 slices in it. So slice 1, slice 2, slice 1, slice 2 for node 1. So in total we have 4 slices and 2 nodes. So that's how my cluster looks like. In many situation, I have seen people does not have access to the AWS console. Maybe some limitations are there. So in that case, if you want to see, okay, what are, and you just have access to Redshift via SQL editor, then probably you can run this query and see how many nodes and slices you have in your cluster. Okay, let's begin. I'll first create a schema, and we'll create all the tables in this schema itself, right? So the very first thing we are going to do is, I'll keep the examples very simple. So we'll create 2 tables, orders and customers. We'll do a join, And then what all permutations and combinations I can think of while creating the table, I have included that. So let's create the table first. And my table is created. If you want to see, you see here I have not given any extra information. It is just column name and data type name. I have not specified any distribution key. I have not specified any sort keys. I have not even specified any encoding, what will be the compression. So if we want to see what is the table definition, I can run show table name, and this will give me the command. So this is how my DDL looks like. And you see here, I have not specified anything, but still Redshift has automatically used encode. Encode basically refers to the compression technique it is following for this column. So you can see here AZ64 and LZO for the varchar column. And the distribution style it has used as auto. So if you don't give anything, by default, the table becomes auto. And in my previous part, I have clearly mentioned that you should refrain from using auto as a disk style, because as when the table size will grow, it will switch from auto to even. And when the table is truncated or deleted, it stays as even. So it does not comes back, and most of the time it will end up redistributing the data while you are doing a join. So if you see here, I've created a table. What I am going to do is I'm going to insert some records, some 50 odd records, random records I have generated, and I will just load that record into this table. And what I will do now is I will run analyze compression on this table. So what analyze compression does is it tells you that, okay, what should be, what is the suggested compression technique, recommended technique for compression for this table and for the columns, and how much reduction in size you can expect if you implement that technique. Now, if here you see all the columns are coming as raw only. Raw means there is no compression. The values are stored as is, and there is no reduction. And there can be many reasons for it, and we'll cover that as well in subsequent SQL queries, right? So this is my default table, no keys, nothing, and automatically Redshift is intelligent enough to apply some encoding into it and keep the style as auto, right? So if you don't specify anything, if you just give column name, table name like this, and data type, you can expect something like this as the output of the table. So if this is clear, what I will do is now I'll create one more table. And this time I'm going to keep encode as raw. Like there is no compression. I don't want any compression. And in some cases, this actually is good, because like for the column for which you are creating a sort key, the columns which are generally used in the filter conditions, it is suggested that not to put any encoding, because keep the values as raw, because when it applies filter on it, it does not have to de-encode it and then use it. So in some cases, keeping values as raw, especially for the sort key column, it is recommended to keep it as raw. Again, I will do the same thing. I'll insert some records into it, the same 50 records into this table as well, and I will run analyze compression on this table as well. So you see here, again, it is suggesting me that, okay, this is raw and estimated. You can keep it as raw, and then reduction percentage is 0 only. You won't see any significant. Now, there are two things. One is vacuum and the other is analyze. Analyze, basically, it's like it will collect the stats. It will get the data demography of the table, and will get to know, okay, what exactly is how much data is there in the table, what kind of data is there, median, mode, all that mean information. Vacuum basically frees up the space, it fixes your sort keys, so many things vacuum does, right? So you can run this on the table as well. I will not run as of now. Why I'm not getting any suggestion? There can be few reasons. I The table information is not clearly available to the optimizer, so it doesn't know how much data is there in the table. It could be that the optimizer still thinks that the table is empty, so there is no requirement for it. So you can run analyze and vacuum, and then check analyze compression, that okay, is it suggesting me anything or not. But what I am going to do here is I'm going to create, since there is just 50 records, in this case, since I already know, the reason is it has just 50 records and 4 or 5 columns in it. The table volume is not that big. And anyways, the physical block is of 1 MB. So that's why we are not seeing any significant improvement in encoding. But I'm sure as the table size grows, the encoding recommendation comes, right? So, but in production, since you're dealing with terabytes and petabytes of data, it is always recommended to have encoding on your table. So to test this hypothesis, what I'm going to do is I'm going to create another table. This time I'm going to load 10,000 records in it instead of 50, and then we'll see. So I'll create a table here and I will run this copy command. So I have placed a file here, a CSV file, and it has 10,000 records in it, and I will load it. And this ARN number, if I come here to the properties, and this is my role, right? So if I see here, this is the role which I have. So I'll just copy this ARN and I have pasted it here. So this is the Redshift role with which I'm going to read this data from S3 and load into this table. And I have specified format as CSV, and there is a head table header also. The very first line has the column header, so I'm ignoring that as well. And this is a good practice because many people, they will just write these 3 lines, they will not. And when copy command goes with some default options, it may work for you, it may not work for you, right? So in this case, like, I have to ignore the header because I have column headers in the file, so I have to put this. Now when I'll run this copy command, it will fail, and I'm intentionally want it to fail because as a beginner I want you to understand this error as well. So if you see here, it is giving me an exception that, okay, it is not authorized to perform S3 list bucket. So what I'm trying to do here is, within a Redshift role, I want to read a data that resides in S3, right? However, this role does not have access. If I come here to this role, it only has Redshift access, right? It does not have any policy related with S3 where Redshift can go and read the data from S3 bucket, right? And this is the error. So now what I have to do here is I have to assign proper privileges so that my role can read S3 bucket. What I will do now here is I'll come here, I will add. If I have to make a very fine grain policy, I will go with inline policy. But for now, to keep things simple, I will just add one policy, S3 full access, not recommended for production. If you want, let me know in the comments box below. I can create another video just dedicated to different policies and how to fine grain policies for Amazon Redshift. I can do that as well. Okay, so now I have granted the privileges. Now if I will run this job, it should load the data, right? And at least it should not give me this not authorized error, right? So let me run this, and I already know it will fail. So you see here, I'm getting an error, overflow for numeric 10 comma 10, right? Now there is a numeric column 10 comma 2 decimal column. And when I'm loading this 10,000 order CSV file, it is giving me an error that, okay, it is failing because a numeric overflow has occurred. So I'm getting a value for this column, which is more than 10 comma 2, right? Now, if I want to debug it, right, how will I do it? I can query this table, select star from STL load errors. Let me run this. And the most recent one is mine. So this, if I see here, it will show you which file it is trying to read. So this is my file. If I come here, and it will say, okay, column length is 10 comma 2, and this is the value, raw line or raw field value. So this is the entire CSV line which is giving the error, and this is the value. So if you see here, 10 comma 2 means there will be 8 places, 8 digits before the decimal and 2 after that, right? If I see here 1 2 3 4 5 6 7 8 9, so I'm getting 9 digit value here, and 9 digit value will not fit in 8 comma 2 or 8.2 type of decimal, right? That's why I'm getting this error. Now what to overcome it, I can either fix the CSV file or I can fix my table structure, and these are very genuine and usual errors you will get in your production environment as well. So in this case, what I will do is I'll simply change it. Let me make it 30 comma 2. So I will recreate the table and run create command. So I am intentionally letting this errors come so that when you run into problems, so you see 10,000 records already loaded, right? Now what I want to do is I want to run this analyze compression again. So if you see here, I put all the encode as raw, and this was our original test what we were doing. that whether if the table size grows, whether we will get any suggestion or not. And that is the hypothesis we want to test here, because I said earlier we are dealing with 50 records, and that's why. And you see here for the order amount column, as soon as the size grows, what happens? It suggests me to switch order amount to AZ64 encoding technique, and this will result in 69% of the storage space which this column is taking, right? So you see here, as and when the column size is growing, the rows are coming, I am getting important suggestion from Analyze compression that, okay, for this column, it is recommended that instead of keeping it as raw, you switch to AZ64 and you will see 69% of reduction, estimated reduction, right? So I'll just rephrase what all we have tested so far. We created some orders table. We created by a default option. And then we saw that, okay, if we create a table with a default option, what all encoding it is automatically applied to a table, what is the distribution style. Then we created another table where we explicitly mentioned that, no, I want to keep all the columns as raw. Then we loaded some sample records in it. Analyze compression we ran to see whether any recommendation we are getting or not, and we see that, okay, there was no recommendation coming. There are a few reasons for it, like vacuum and analyze is missing on the table. The optimizer does not have the stats for it, so it could not recommend it properly. Or it could be that rows are, there are very less rows in the table, so switching encoding is not making any significant impact. So to test that hypothesis, we created another table with 10,000 rows. We encountered a privilege issue, we resolved it. Then we encountered a numeric overflow error, we resolved that as well. And then we see how to see the errors. And after that, once the data was loaded, we run the analyze compression again. And this time it is showing us that, okay, for this column at least, if you switch to AZ64, there will be approximately 69% of reduction. So you can see here that analyze compression is a good thing. You should test it often in your production environment. Now, what I want to do is I have designed a table. Now I want to create a proper table. I've done some experiment with my order table. This time I want to create a table with proper keys column, distribution key and sort key, and also the primary key. Although in Amazon Redshift, the primary key and foreign key are not forcefully enforced, but it is still recommended that you should define your primary key and foreign key whenever it is appropriate. And it is for informational purpose only. The optimizer will never enforce these constraints. So in your ETL logic or the ELT logic, you have to make sure that whatever data you are inserting into the table, it respects the primary key and foreign key relationship, but Redshift will not enforce the constraints, right? However, it is still recommended that you mention it in your table, because when it is creating the plan, optimizer is creating a plan, it creates more efficient plan, because it has the information, okay, this is a foreign key and primary key relationship, so joins will be better, your plans will be much better, right? So here in this case, that's what I am doing. I'm defining a primary key also in the table, I'm defining a distribution key in the table, and I'm defining a sort key also in the table. And all these concepts we already know in part 1. I have explained it. So let me create this table. Table is created, and I will load the data into this optimizer, same 50 records into this optimized tables. And let me run analyze compression and see if it is suggesting me anything now or not. So see here, it is suggesting me, okay, AZ64, and for rest of the columns, it is saying you can keep it as raw, right? And the hypothesis was, since there are just 50 records, it won't make much difference. So although I have proactively determined the encoding with some guesswork and I've used it here, but yeah, even if I kept it as raw, it wouldn't have made a lot of difference, because there are just 50 rows in the table. But if would have been 5 lakhs or 50,000 records, I'm sure encoding, we would be seeing encoding for all the columns here, right? Now we have designed a good table, right? When I say a good table, it follows the guidelines or the basic principles of defining a primary key, defining a distribution key, defining a sort key, proper encoding into the table. I think these are some of the basic things which you must cater to while creating any table in Amazon Redshift. Next, I want to see this table in performance. Performance in the sense when joining with some other table. So what I'm going to do here is I'm going to create another table, customers, with just 2 columns in it. Let me, and again here also you can see I'm mentioning the encode and the keys and everything. And I will load some sample records, again 50 records into this table. It's a very small table, just 2 columns in it. So now I have orders tables, I have customer tables. Order tables, I have different versions of it, the default one, the raw one, the optimized one. And then the customer tables, I have created a good basic structure of that, and I will join these different orders tables with my customer table. Now I don't want to focus a lot on the output, but I want to focus more. Let me just run one query to show you. The focus should be more on the query performance rather than what is the query output, right? So this is, it is giving me some output, but what I want to focus as part of this video is the explain plan. So the explain plan is generated for the first query, and we'll see what it is. So you see here I am joining the orders default table with the customer. So orders default table has encode this style as auto. So as I explained in the part one, auto starts with all when the data volume is less, and then it switches to even. So if I see here, it's auto. So I will. So here what is happening is in Redshift, we read explain plan from bottom to top. So first it is just scanning the orders default table, then it is scanning the customers table, and then there is a customer ID join, and it is doing not distribution right now. And the reason being is this distribution all none means there is one table which is involved in the join is having all as a distribution style. So that table is present in all the nodes. So there is no redistribution required, because for one table we have a key which exists across the slice, but the other table is available in all the slices, right? So it does not has to redistribute, but still it is not very efficient, because if it would have been key to key join, you will join one row with another row. But here what is happening is there is one row coming from the key column from the table which has dist key in it, and all the rows from the other table are coming, and then it is joining. So it is still efficient in a sense that node redistribution is required, but still it is not very efficient, right? Now let's see, this was this orders default which has this style auto. Now we'll join with orders raw, and then we'll see how the explain plan looks like now. So you see here similar plan is generated here as well, because orders raw also is auto, and it has right now it is in all mode. If the table volume will grow, it will switch to even, and then if it would have been even, then there will be some redistribution happening, and we'll test that as well. And when we check with optimized one, let's see how the query plan or the explain plan looks like. So if you see here it is scanning the customers, it is scanning the orders, and then it is joining, and this time distribution none. It means there is no distribution. Distribution none is the best use case for joining two tables, and this means that both the records of the tables are present in the same slice. So one key, both are joining with each other. There is no redistribution required. So distribution none is the best case. Distribution all none is also good, but it is not as efficient as distribution none. What we will do here is we will create, let me create one more table here, which is raw even. So what I'm going to do here is I will create this raw table, but this time instead of this style auto, I will create this style even, right? And in auto it starts with all and then switches to even. So what I'm doing here is I'm switching to even first right away. And now let's see how the explain plan will look like. Will we see any changes or not? So I can see that there are some changes in the explain plan now. See here, it is saying that okay, run the analyze command, this table is missing stats. But here is the main difference, right? You see, it is broadcasting the inner table. Broadcasting the inner table means it is the smaller table, it is moving to all the nodes and slices. So it is actually broadcasting the data from the inner table, right? So you see here, it's already from all none to dist none to broadcast inner, means it is broadcasting. If the table volume would have been very much, or if the table volume was more and it is not able to broadcast it, it will go for the redistribution, which is a worse scenario. So we want to avoid the redistribution. Similarly, what I want to show here is, even if you are creating an optimized table, but the table does not have the same disk key. So in this case, you see, I have changed the disk key from customer ID to order ID. Let me insert some records into the table. So table structure as such is optimized. I have defined the proper encoding. I have a primary key. I have a distribution key. I have a sort key, everything. Only thing is, in my join, I'm using a column which is not my distribution key. I'm using some other column. So let's see how the explain plan will change now. And you see here, the explain plan has also changed. And here it is again doing the broadcast inner, right? And I'm telling you, if the table would have been big, like say 50,000, 50 lakh records, it would go for redistribution, which will take more time, right? So here you see it is again broad, although the table is optimized, but it has a different key column which we am not using in a join. It will go for the broadcasting of the inner table. So this, I'll keep this example simple. I'll keep it till here only. Take a pause, go back, see the video again. And this is actually a very important concept. This is a core concept. If this is 100% clear to you, you can be sure that you can grow very well in Redshift performance optimization, right? Now, this is about a basic SQL query performance optimization, considering what you can do in your table design. There are obviously different ways of rewriting SQL queries, like you have a partition, say you have a product join or a Cartesian join, and then you fix that. So there are other ways. I will not cover SQL tuning, like by rewriting SQL in this part. I want to focus on the Redshift only. So by table design, this is one way of optimizing your queries. The other way is, obviously, as I mentioned, you run the vacuum and you run the analyze commands. So this refreshes the stats. This frees up the space if you're running deletes and other commands, GML commands on the table. There will be a lot of space which is not used but still occupied. So vacuum will free those space. It will fix your sort key orders as well. So in the on this table we have sort keys, so it will fix that as well. So these two are also very good way of optimizing your table data demography, and then optimizing the queries. Most of the Redshift system will automatically run vacuum and analyze on the table. That's why Redshift is called kind of an auto repair database, where it automatically tunes your queries by automatically tuning your tables, underlying tables. There is another way of creating an optimized query output is by using materialized view. So materialized view is like pre-aggregated, pre-calculated data which is stored. So it physically stores this data, and next time whenever my query is running this kind of a join, it will join or aggregation, instead of calculating it at runtime, it will directly read the data from materialized view, right? So materialized view, vacuum, analyze, distribution key, sort keys, mentioning primary key, foreign key also. So all these things are something which you can do in Redshift to optimize your queries. There are always ways of writing better SQL queries which are applicable to almost all the databases. But in this part of the video, I wanted to cover this only, that what are things are specific to Redshift which you can try for optimization, right? So we did a lot. I will keep this video till here only. I will not extend it further. So if you're a beginner, I've kept the examples very simple. I hope this helped you. Check your nodes and slices, how many nodes and slices you have, and then create a optimized table with proper encoding and your distribution keys and your sort keys. If you already know, mention primary key and foreign key as well. Run vacuums, analyze, right? We ran some copy command as well. We encountered privilege error, we fixed that. Then we encountered numeric overflow error, we fixed that as well. And we saw that how analyze compression was suggesting us that, okay, you can change from raw to the other encoding technique to save around 69% of the storage space for that particular column. Then we also ran few simple queries to see how the explain plan was changing. As and when we were using the optimized table, there was no distribution required for the optimized table, because both the distribution keys were the same and the data resides locally to the slice, right? So that's it. Yeah, hope you find this video helpful. If there is any confusion or queries, drop a comment below. I will try to respond it. Thank you. Happy learning. And again, if you are new to the channel, please subscribe. This really motivates me. Thank you. Bye bye.